Hi guys, and welcome back to Mindset Learn. This is physics and we are having an awesome time here on the grade 10 show. So, Mwepone says that she cannot wait for the grade 11 show, but I think it's kind of awesome that you're watching the grade 10 too. Doctor, you're always here. I have to do a shout out to you because we think that you rock and we think that you are absolutely awesome. Always on the page. So, what we're going to do, Phil, we're going to get straight back to you to learn more, learn extra. Take it away.
Thanks so much, Indy. Okay, well, you guys are probably wondering what type of calculator is in store. If you haven't seen one, this is a really big version of it. Okay, they're really, really awesome. Okay, the Casio calculator up for grabs. Okay, so before we went away for the break and let you guys rest a little bit, I thought we'd give you a little bit of time out. I wanted to turn 3.5 centimeters back into a real life distance. Now, what I've done is I've rewritten my scale, and this is how you guys are going to do it as well. Okay, so now I'm going to take my scale and I'm going to write in the thing which I have. Do I have centimeters or do I have meters? Well, 3.5 sounds like centimeters. I've got 3.5 centimeters. All right, now I'm going to be using that beautiful calculator and we're going to be working out how many meters that is. Just a reminder on how to work with your ratios. If you write them this way, you can make a window out of them. That's a very nice way to do it. Now what you can do, if you flip over this line over here, now we're going the other direction, but the same rule applies. So first I divide, and then I multiply, and then I push equals. So let's do this together. I'm actually going to show you how awesome this is on this calculator. So let's do this together. There we go. Right, we've got a little bit of space. We can see what we're doing. Okay, so I'm going to take 3.5. Instead of 3.5, there we go. Now I'm going to make it into a fraction, so let's put it into a fraction, and that's the wonderful thing about this calculator, it just does it for you. 3.5, I divide by 2. Now let's make a little bit of space to multiply by 10. So I hope you can see why I'm dividing first by 2 and then multiplying by 10, and then out comes my answer, and I've got to push my S to D button. There we go, changes it back into a decimal, so 17.5 meters. That's great. So what we're going to do is write in my distance over there, so 17.5 meters. Now, I cannot give this as my final displacement. Let's just write down what we know so far. I know the difference between my distance and my displacement. Here we go. So my distance, let's just add up all my distance. This is how far I walked. My distance was equal to 20 meters plus 10 meters plus 5 meters. And by then I was quite tired. So I added all of that together. So I got 10, I got 20, I got 5 as well. Okay, so now I've got 35 meters of distance. Okay, but now that doesn't tell me anything about where I landed up. That's all that distance can do for me. It just tells me I walked 35 meters. Doesn't tell me if I walked 35 meters up the building, down the road, onto the rugby field. It doesn't actually matter. Now, displacement. This is where the useful information comes in. So now distance, if I turn this into something slightly more useful called displacement, we can actually start to write it down in a much more meaningful way. Now let's compare this with the displacement. Remember that displacement is only measured from the beginning right to the end. Okay, so now displacement. Displacement simply is 17.5 meters. But now you guys at home are smart enough to know that I can't leave my answer this way. Displacement is a vector. Now, I've got my magnitude, I've got my unit, I need my direction. So let's try and figure out what my direction is. And the way that I'm going to do that is I'm going to whip out my handy protractor. Okay, so let's whip out one of those. Now, very lucky for me, I've always got one in the studio. There it is. Let's just make it a little bit smaller. There we go. So now let's put it on the middle there. And let's start figuring out how many degrees from north this is. Now, there's a couple of ways that you can actually give this direction. So now if I put 0 on north and I start measuring around, I can start to find my displacement. So now I think that's almost 0. Let's just make sure that it's absolutely precise so that you guys don't get on the line and say, oh, it's not correct. Let's actually measure our degrees. I'm going to make this even smaller. Now the only reason I'm doing that is so that I can draw a nice line to show you what I'm doing. So I start at 0 degrees over here. And what I'm going to do is I'm going to measure all the way around here to over here. Now, you guys probably can't see this at home, but over there, I'm measuring a degree of 128. So what I'm going to do is I'm going to write that in as a bearing. So now, if you guys are busy trying to solve the challenge question, and I hope you are, I'm going to write my displacement, and bearing is one of the ways that I gave you directions. So a bearing of 128 degrees is inside there. There we go. We've got a magnitude, we've got a direction. That means that I've got a vector. But what I think we should actually do
Yes.
is I
The
think
challenge
it's
question.
time.
Did you see me getting nervous there, Phil?
Absolutely. You thought I'd forgotten.
I had.
Okay, well, what we're going to do is we're going to put you guys out of your misery. I'm going to be explaining the challenge question to you guys. So let's jump right back to that. Let's go back to our map. Okay, now most of you guys managed to figure out that there is only one way that I can get from the start to the finish in terms of displacement. So what I'm going to do is I'm going to show you that no matter how you actually navigate through here, you're going to travel the same distance.
Phil,
Yeah.
can I ask you a quick question? Because
Absolutely.
Charmaine's been up on the page. She's posted the answer and whatever,
Absolutely.
what she thinks it is. But I think maybe this might help. She wants to know, what is the difference between displacement and position?
Ah, very
Before we
good question.
start, yeah.
Okay, now a position tells you where you are. It doesn't tell you any distance that you've moved. So a position might be at this position on the graph. Now, a reference to position tells you where you start and where you end. It doesn't tell you that you've traveled anywhere. Now, what I'm going to do is I'm going to use the word position and try and figure out what it means in terms of vectors. So now my starting position to my end position. Let's try and figure out how I get from one position to the other. A position is just a place. So now if I was to say to you, your position is on the couch. Your kitchen is 5 meters from your position. I hope that sort of starts to clear it up, but we're going to use it a couple of times in the way that we describe this. Okay? So what I'm going to do is I'm going to go from that starting position and we're going to start to get distance and displacement. So now I'm going to figure out a route to get from my start to my end. Let's do that. So I'm going to start from my beginning and we're going to turn some corners and let's navigate through the middle. Now, it doesn't really matter which way you do this. What I'm going to find is that I'm going to get a really large distance. Each one of these is 100 meters long. Now, most of you are saying, okay, well, then there's 100, and there's 100, and there's 100. Okay, so that's 300, 400, and 500. What you've done is you've fallen into the trap. What I've done there is I've measured out the distance. This is not the displacement. Now, it doesn't matter. The way that I've designed this is that no matter which route I take, it's going to measure 500 meters. Now, a lot of people say, which way is the shortest way? There isn't one. Whichever way you go through these blocks, you're still going to land up with 500 meters distance. Even if I go around the outside, I go 100, 200, 300, 400, and 500, I'm actually landing up with exactly the same amount of distance. So there is actually no shortcut between a row of two. So it doesn't even matter if you go around the top. You're still going to get a distance of 500 meters. But that's just it. That is just a distance. Okay, so that means that the distance ones are out. So if you answered option B, I'm sorry. That means that you fell into the trap of distance. Okay, now that was a distance. If you answered D, also, that is a distance. Now that leaves us only with two other options. 360.56 now. Is it the bearing? Is it southwest? Well, there's a couple of easy ways of telling. What I'm going to do is I'm going to use a nice fat arrow, but first, let's just clean this up. Let's just make sure that everyone can see what I'm doing. Let's just get rid of all this writing, and let's just see what to do from start to finish. So now, if I go from my start to my finish, I'm even going to forget about the 100 meters for the moment. What I'm actually going to do is I'm going to draw a line which goes right from the beginning to the end. And for that, I've saved a nice big fat red line. So now, if I go from the start to the end. Now, if you did this by graphics or if you did this by Pythag, it didn't really matter. I'm going to show you how to do this by Pythag as well. If I start to make a triangle over there, what you'll notice is that I can actually make a right angle triangle out of this. Now, this is one of the ways that you can actually figure out how much vectors are when you add them together. So now I've got two sides of a Pythagoras triangle. One of those sides measures 300 meters, and then the other side measures 200 meters. Now, if I take those two and I find the Pythagoras hypotenuse between these two, you'll find that it is 360.56. So that's where the distance comes from. That's where this length comes from. The question is, how do I figure out this bearing? And this is quite complicated. So what I'm going to do is I'm going to pull up that handy protractor and we're going to start measuring. Now, what you'll very, very quickly find out is that you cannot actually get this to be southwest. So that gives you a little bit of a further clue. Now, this angle is not 45 degrees inside here, and that's why it is not southwest. So I don't know if you can see my protractor, so I'm going to make it nice and condensed and small. What you'll actually notice is that southwest is 45 degrees off from west. And I'm going to show you why this is not the case. So what you can see over there is that this is actually only around about 30 degrees off there. If I measure this angle over here, I find that the angle is much, much smaller. Now the question is, where does the bearing come from? I've immediately told you that this is not southwest. So how on earth did I get to this crazy bearing of 213? How do you go past 180? Well, I'm going to show you. All you've got to do is you've got to realize that you always start from north. So I hope that you can see that my protractor is now with its 0 on north. Then what I do is I start again at 180. So now what I mean by that is I'm going to rotate all the way around again. And what I'm going to do is I'm going to add whatever angle I get there to 180. Now if I add that original angle to 180, I find that my total degrees over here is 213.7 degrees. And that is a bearing as well. I'm just going to redraw that because I'm pretty sure we're going to get some questions about that. Is that if I do that, and I've got my final displacement over there, let's just make sure that we draw it in a final color there. My final displacement, remember, was down there. I take 180 over there, and I add it to an extra angle over there, because remember, we start from north, and this is how to do bearing. I have measured an extra angle over there, and that is how to get my bearing of 213.7. So the correct answer today is A, and I think that's all we've got time for.
I think so too, but I know already that there's a mindset that's jumping up and down on her couch going, I got the right answer, and she knows exactly who she is, and that is Charmaine. You were the first person to get the correct answer in, and not only that, you helped other mindsetters as well. That makes you an awesome mindsetter, so you win this awesome Casio calculator. I'll be letting you know on the page how to get it sent to you. Thank you so much, mindsetters. We'll see you same time, same place next week. Liberty, thank you so much. You guys rock. Thank you for making the show happen. We had an awesome time. Thank you guys. You make it all possible, and have a fantastic day. Bye.